In the name of Allah, the most gracious, the most merciful. Good morning, everyone. Now we are going to deal with our new program for mathematics department in Tabarak Private School with you, teacher Muhammad Al-Badri, with grade 11 mathematics teachers, and we are going to deal with the lesson of the sum to infinity. And before everything, we have to say big thanks for the chairman, Mr. Yunus Al-Rahbi. Now we are going to start with our new lesson, the sum to infinite.
In the name of Allah, the most gracious, the most merciful. How are you, my dear students? I am Mr. Muhammad Al-Badri, teaching grade 11 bilingual. I want to welcome you to our private school, Tabarak. And from our educational platform, we have to thank our chairman, Mr. Yunus Al-Rahbi, who gives us this wonderful opportunity to contact with our dear students and know what is our lesson today. Our lesson today is transformations. How could we make a transformations for the parent functions? So firstly here, transformations of functions and the graph. We will be looking at sample functions and seeing how various modifications to the functions transform them. So firstly here, please focus with us, very important. Firstly, we have a vertical translations. For the translations here, vertically ups and down. For the translations here, vertically ups and down. On the above here we have a function of x equals x squared. If you want to make a translation, how could we do it here? What would function of x plus 1 look like? This what means taking all the functions values and adding 1 to them. So that means the blue one, function of x equals x squared, becomes function of x plus 1 equals x squared plus 1, the red one. We move it 1 unit up. So again here, what would function of x minus 3 look like? That would mean taking all the functions values and subtracting 3 from them. So we are going to take it down. It will be function of x minus 3 equals x squared minus 3. So now what is the difference between the red and the green? The red we take it and move it 1 unit up, and the green we move it 3 units down, because here we have negative 3. So as you can see here, a number added or subtracted from a function will cause a vertical shift or translation in the function. Now here, a vertical translation, another example for it above. Here we have the graph of modulus or absolute value of x. What would function of x plus 2 look like? So here it will be up or down. Yes, it will be up. We are going to move the function 2 units up. It will be the red one. Function of x plus 2, that means modulus of x or absolute value of x plus 2, the red function. Again, what would function of x minus 4 look like? We have to move the blue lines 4 units down, because we are going to subtract 4 from the values of the function. So the graph function of x plus k, where k is any real number, is the graph of function of x, but vertically shifted by k. If k is positive, it will shift up. If k is negative, it will shift down. Now horizontal translation. Above graph, it's about function of x equals x squared, the blue one. What would function of x plus 2 look like? It will be this would mean taking all the x values and adding 2 to them before putting them in the function. That means the blue quadratic functions, we are going to move it 2 units to the left. What would like function of x minus 1? That would mean taking all the x values and subtracting 1 from them before putting them in the function. We are going to move it 1 unit to the right, like what we have on the green parabola. So as you can see, a number added or subtracted from the x will cause a horizontal shift or translation in the function, but opposite way of the sign of the number. Very important. Now for the horizontal translation, we have another example about the cubic. For the horizontal translation, we have another example about the cubic function. We have to know what would function of x plus 1 look like. Directly if you have plus 1, so we have to move it 1 unit to the left, the opposite direction of the sign. It would be the red one, like what we have. What would like function of x minus 3 look like? Now we are going to move it 3 units to the right. It will be the green one. Function of x minus 3 equal x minus 3 cubed. This is the rule. So the graph function of x minus h, where h is any real number, is the graph of function of x but horizontally shifted by h, and we have to type the negative. If you set the stuff in parentheses equal to 0 and solve it, will tell you how to shift along x-axis. So the graph function of x minus h, where h is any real number, is the graph of function of x but horizontally shifted by h. Type that the negative. If you set the stuff in parentheses equal to 0 and solve it, will tell you how to shift along it. So here, like what we have, x minus 3 equal to 0, so x equal to 3, so shift along the x-axis by 3. This shift right 3. Here again, we have it here 2 left and 3 and now for the stretching and compressing. If you multiply a function by a non-zero real number, it had the effect of either stretching or compressing the function, because it causes the function value and the y value to multiply by that number. Let's try some functions multiplied by non-zero real numbers to see this. Dilation. Here we do it. Firstly, here we have a function of x equal absolute value of x. This is the standard function, and what would 2 times function of x look like? So here it was the blue and it becomes the red. When we multiply it by 2, it becomes closer to the y-axis. If we multiply any function by an integer like what we have here, becomes closer to the y-axis, becomes more thinner. Notice for any x on the graph, the new red graph has a y value that is 2 times as much as the original blue graph's y value. What about 4? It becomes more thinner, becomes more closer to the y-axis, like what we have here for the green one. So 4 times function of x equals 4 times modulus x. And says for any x on the graph, the new green graph has a y value that is 4 times as much as the original blue graph's y value. So the graph of a function of x where a is any real number greater than 1 is the graph of function of x but vertically stretched or dilated by a factor of a. What if the value of a was positive but less than 1? Fraction smaller than 1, like half function of x. We said it, if we have an integer greater than 1, it becomes closer to the y-axis, nearest to the y-axis. If we have an integer multiplied by the function greater than 1, but if it's smaller than 1, it becomes far away the y-axis, in like the red one. It was a blue in like the red one. It was a blue becomes red, half modulus of x or half a function of x. That means for any x on the graph, the new red graph has a y value that is half as much as the original blue graph's y value. What about 1 over 4 function of x look like? Becomes more wider, more far away from the y-axis, like the green one. 1 over 4 function of x equal 1 over 4 modulus of x. For any x on the graph, the new green graph has a y value that is 1 over 4 as much as the original blue graph's y value. So the graph of f(a) function of x, where a is greater than 0, smaller than 1, is the graph of function of x, but vertically compressed or dilated by a factor of a. Now, what if the value of a was negative? About the graph here we have the function of x equals modulus x. What about if we have it here negative function of x look like? We have a reflection here. Yes, it was a blue one, function of x equal absolute value of x, and if we make a negative, we have reflection on the x-axis, the red parabola. For any x on the new red graph has a y value that is a negative of the original blue graph's y value. So the graph of negative function of x is reflection about the x-axis of the graph of function of x. The new graph is obtained by flipping or reflecting the function over the x-axis, and we have the x-axis becomes the line of reflection. Here we have there is one last transformation we want to look at. Here we have a cubic function, and now what would function of negative x look like? This means we are going to take the negative x before putting in the function. So now here, what's the difference between what we have now and what we just studied in the previous exercise? The negative sign, it was outside the function, so we make a reflection on the x-axis. But the negative here is inside the function, so we are going to make a reflection on the y-axis, like what we have here for the red parabola. For function of negative x equal negative x power 3, function of x equals x cubed for the blue parabola, and function of negative x for the red parabola. For any x on the new red graph has an x value that is the negative of the original blue graph's x value. So the graph of function of negative x is a reflection about the y-axis of the graph of function of x. The new graph is obtained by flipping or reflecting the function over the y-axis. I hope you enjoy with our new lesson here, and here we have the line of the reflection in the y-axis. We have a summary for all what we studied here, summary of transformations so far. The reflections and dilation before vertical and horizontal translation. Very important note. Here we have a times function of x minus h plus k. How could we do it? Firstly, here if a greater than 1, then vertical dilation or stretch by a factor of a. If we have a greater than 0, smaller than 1, then the vertical deletion or compressing by a factor of a. Now, if a greater than 0, then reflection about the x-axis as well as being deletion by a factor of a. And now here we have, if we have function of minus x, reflection about the y-axis, and if we have k, we will have vertical translation of k. And for the negative here, horizontal translation of h, opposite sign of a number with the x. And here we have graph function of x equals a negative 1 over x minus 2 plus 1 using transformations. We know that the graph would like if it was function of x equals 1 over x like what we have it here, and we have to know how many transformations. Firstly, we have to make reflecting and stretching. Yes. Do we have here stretching? No, we don't have any stretching. We have only reflections because we have a negative sign, and we have translation. So let's do it here. Reflect about the x-axis because we have a negative sign, becomes the green bubble, and we have to move it 1 unit up, it becomes the yellow one, and we have moved to right because it will be the red one, the rose one, sorry, and the answer becomes like what we have here. There is one more transformation we need to know. The reflection and deletion before vertical and horizontal translations. If a greater than 1, like what we have here, then vertical deletion or stretch by a factor of a. If a greater than 0, smaller than 1, then the vertical deletion or compressing by a factor of a. If a smaller than 0, the reflection about the x-axis as well as being delayed by a factor of a. And if k, here we have it like what we have, vertical translation of k, a function of negative x reflection about the y-axis. And here we have horizontal translation of h, opposite sign of number will be x. The last one, horizontal deletion by a factor of b. If we have it here divided by b, so horizontal deletion by a factor of b. If we have it multiplied by b inside the function, it will be horizontal deletion by a factor of 1 over b. It will be very important, please, folks. And now I want to thank you for your listening, and I hope you enjoy with our explanation, and let me say goodbye.
Thank you for listening for our explaining, and I hope you enjoy with us. And the homework, you can find it in the model and in your contact number in the WhatsApp and on the model. Thank you very much.